Okay, good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects, titled Creating Math Moments That Matter with Kyle Pearce and John Orr. We have a very large group tonight with mostly experienced users, and I'm sure it's going to be a really fun and interactive session with Kyle and John at the helm. Comme toujours, je voudrais profiter de l'occasion pour dire quelques mots en français et souhaiter la bienvenue à nos collègues franco-ontariens. Cette session est en anglais, mais si vous désirez obtenir des informations en français concernant notre programme, surtout n'hésitez pas à nous contacter par la suite. We are definitely thrilled to have each and every one of you with us tonight, mostly from the southern part of the province. And it's also our absolute pleasure to welcome Kyle Pearce and John Orr. Most of you already know Kyle. He's one of our most experienced facilitator and is quickly becoming an ambassador for Ontario mathematical excellence overseas. He actually told me that he just returned a few days ago from the National Council of Teachers of Mathematics in Orlando, Florida. I guess he made a presentation there, I suppose. Kyle is a mathematics consultant with the Greater Essex County School Board. He works on new and creative ways to spark students' curiosity using online tools that are both fun and visual, and we're going to do that tonight as well with you guys. He shares his work by leading professional development seminars in mathematics and the effective use of technology. He's also an Apple educator and trainer, and he's also a talented musician. I've heard much praise in the past about his wonderful guitar playing skills. If you want to learn more about Kyle, you can go and visit his website. I'm going to post that for you in the chat box right now, and I will post it again at the end of the presentation if you want. John, on the other hand, is new to OTF Connects. It's the first time that I'm working with him tonight. He's a math teacher at the John McGregor Secondary School in the Lambton, Kent District School Board. In the last few years, he has led a numerous number of workshops and presentations on teaching pedagogy in the math classroom. He's also an Apple educator and often talks about implementing technology in his classroom. And not unlike Kyle, John has a subtle sense of humor and refers to himself as a bit of a technology geek when it comes to promoting and talking about mathematics. And you can follow John on Twitter and on his website called MrOrIsAGeek.com, and I'm going to post that as well in the chat box. So here it is. And so that's it. I have introduced John and Kyle. I don't know, Kyle or John, who is starting the presentation, but if you want, you feel free to click on your microphone and jump in. And okay, Kyle, you're starting. That's excellent. So, I wasn't sure.
Michelle, that's
go ahead and excellent.
Thank you so much for such a great introduction, and we're so excited to be here tonight, and it's great to have a co-presenter. I'm actually at John's house, so we're going to sort of be sharing a mic here, and we're really excited to share this presentation on making math moments that matter. So to begin, I know in the chat box I had already posted a link. I'm going to post it again for Knowledge Hook's game show. There's a link, khmath.com/play, and we're going to have a game pin Guru 2447, and you're going to join in as a guest, and that's for uploading solutions. We've also got links embedded to some videos in there as well, so it'll just be a little bit easier to follow along and also upload some of your thinking. We're going to use a couple digital tools throughout. So we see some people already logged into the game show room, and we'll wait for a few more before we actually hit the play button on that. In the meantime, for the rest of us, as you're logging in, we want you to think back to a memory, something that comes to mind. And we've got a couple images up on the screen here, some from my family and my experiences, some from John's. Take a moment. We're going to give you about 20 seconds. Think about a moment that comes to mind when you think of something memorable, and we're going to have you share that out in the chat box. So we'll give you those 20 seconds to think, and then we're going to share that out. And feel free to comment on anyone's sharing as if you're talking to a neighbor.
Okay, these are great memories that we're seeing here, and there's so many memories that always come to mind. What we want to do now is we want to take it a little bit into the math realm, and we now want you to think not about a personal experience, about family or anything, but we want you to think about a math experience as you as a student. So thinking back to your time from kindergarten through to grade 12 as a math student, and we want you to think about what was memorable about that experience. So something that comes to mind, sometimes the best thing to maybe to jot down in the chat window would be that first memory that pops into your mind, good or bad. Give it away there. I'll start off with one of mine. Just to get things rolling, and then Kyle will give it a few minutes, and Kyle will jump into one of his. I'm always when I always remember my math experience, I think now you'll have to judge me on what kind of math student I was, but what comes to mind is this: my teacher would always send home math questions for me to do, and it was about multiplying in grade 4, and I would do them and do them and do them, and I think. What I didn't know at the time is they were above and beyond what was expected, and I would come back and he would slap this sticker on the front of the work, and it wasn't one of those just normal stickers. You know what I'm talking about? It's not just a sticker that just flaps down. This is a sticker that like sticks off the page. This is like you close the book and it doesn't close all the way. It's like one of those puffy stickers, and I think you guys know what I'm talking about. So that always sticks in my mind, and so sometimes I did pretty well, and sometimes I didn't. And another thing, this is separate, and I'm not sure because my mom actually just brought this test back to me, and I know this is definitely the same grade, but definitely a different memory. I don't know if they related to each other or not, or one came before the other, but I had this test that the teacher wrote terrible, worked carefully on it, and it also reminded me of my math experience in grade 4. So one being I had this great sticker, and then another experience in the same year saying I was a terrible math student. Sticks in my memory a little bit. So feel free to share in the chat window some of your memories. We'll give you a minute there, and then Kyle will jump in and share his experience.
Awesome memories we're seeing coming up in the chat box. You know, now that John shared some of his memories, I was so delighted when he had emailed me these pictures this past weekend. His mom dug them up and found this super thick sticker that he had been referring to when we had presented this very same presentation in the past. For me, my memory is actually of post-secondary. mathematics. Throughout K to 12, I was typically one of those kids who, the teachers would say, he sort of gets it, doesn't really need the extra help or anything like that. But when I was in post-secondary, going through in my second year of my math degree, I had a professor who looked me dead in the eyes and pointed at me and said, "You don't know anything about math." And at that point, I just thought he was, just sort of a rude individual. I didn't really think much of it. But about 10 years later, as a teacher, I started to realize what he meant. And he actually asked me at that time, he said, "Well, what is a quadratic?" And this was in second year university. And I remember just thinking to myself, I have no idea. Like, I don't know what it is. And he said, "Factor this." And he gave me a trinomial, and I factored it. And he said, "That's a quadratic. You don't even know what you're doing." And it really, about 10 years later, teaching made me realize that, I really need to start thinking differently about how I'm teaching math, because I had a lot of students that reminded me an awful lot of myself. So that's my math memory moving forward. What we want to do for you here is give you a moment to actually see what the students said. And we're going to post the Vimeo link in the chat for you to take about a minute or two to watch this video of different students giving their thinking or their memories of math class. Some students interpreted it as what they liked or maybe what they disliked. And then we'll be coming back. We're also going to send this down through Game Show. So I'm going to do that now. I see we have about 20 people in our Game Show room. So if you have a Game Show on a mobile device or in a new tab, you should see a new question coming down with a video that you can actually play. If not, we're going to post this up in the chat, and I'll get that in there for you in just a moment. And then we'll come back to share it. There, people see it.
So if you just finished watching the video on Knowledge Hook in the game show, on the side here it says click when you are finished, and if you click that, I think it'll pop up saying submit. If you submit that, that tells Kyle and I that you've seen that video. And if you're watching on Vimeo, we're going to give you another about 20 seconds to finish that off, and then I do want to chat about the last little bit of that. I find it pretty funny, and so we'll do that in about 10 seconds. So if you just watched the last video, I always got to have a kick about that kid who says math is homework, and it blows my mind. Like, how much homework in kindergarten is he really getting? Like, what experience has this kid just gone through to think that that's what his image of math is like, or what's happening at home for him to say that's his image of math already in kindergarten? Can you imagine him going up the grades already with this image of what math is like? So sometimes it's like we have these memories of math and of math class, and I bet that most of us, it's not the math that we remember. It's much more than that. It's about feeling and what's going on behind the scenes and things that are happening in the class. And I know that most of us experience the math class kind of like this. That math class was always, and this is to me what math class was always like, and it was like this for me as a teacher for my first 8-9 years. And this is math class. See if this is familiar. That job number one in math class is that homework must be taken up. The teacher takes it up, or the teacher asks the students to put it up on the blackboard and they check it, but like it's in the manual for a math teacher to put their homework up or take up that homework. And then what always happened after the homework take up was the teacher always introduced the definitions. They wrote on the board, today we will learn about blank. And even lately, it's thou shalt write on the board, today we will learn about blank. And they introduced all the formulas that we're going to need and step-by-step procedures and algorithms. The teacher then says, okay, we're going to write some examples down, follow these exact examples and put them in your notes, because those examples are what's going to be on the homework. And then the homework happens in class, and then we repeat and do that all over again. That's, to me, what math class was like for many years, and I'm sure this looks very familiar to a lot of you as you're experiencing math class. Both Kyle and I, for the last few years, have been actively trying to change what our math class looks like and what our kids are experiencing. We're going through, we started our journey with kind of almost a big question of like, let's get our kids engaged. And it's interesting that we started to jump into the 3-act math realm. We started creating videos, and the interesting thing that was so amazing that came out of this wasn't necessarily that it was a video, and that's kind of our big push here tonight, is that people would say to me, you know, John, like your kids must be so engaged because they're watching this clip, this video clip that you're in, and then we can do the math around it. It's so real world. And I want to argue it's not just that we are watching a video clip. And if you've had some experience in trying 3-act math problems in your own classroom, you probably know that you've maybe had times where it flopped and times that were successful. And today we want to talk about what will make it successful, because I've had those times it flopped and those times that was successful. And we think it's so much more behind the scenes of what the teacher has to do than just putting a video in front of the kids and saying we're going to solve a real-life math problem here. And we've kind of boiled it down into, Kyle and I put our heads together the last 6 months and saying what is going on in our classrooms that make them successful and not make them successful. We've come down to three big things. And the first one we think is what most people think about. Most people see this as the video part, that we want to spark curiosity in our students. And this doesn't have to be a video. Sometimes it is a video. Sometimes it can be real world. Sometimes it doesn't have to be real world. But we definitely want those best moments in our classroom are sparking our kids' curiosity, like pulling them into the math. We want that always to happen. And tonight we want to share with you some strategies to help make that happen in your classroom. The second, Kyle's going to jump in here and talk about the second.
The second one is one that I think we sort of missed for at least the first handful of years when we began trying 3-act math tasks and creating these videos and really thinking, like John had said, thinking that it had to be real world. And now we see that it doesn't necessarily have to be real world. It has to just spark that curiosity. But if we leave it at that, if we just spark curiosity and then we call it a day, students actually miss the mathematical understanding. So the second piece, and probably the most important, the reason we want to spark student curiosity is so that we can get to a place where we fuel sense-making. So, and yes, Joe, we are talking about 3-act math tasks, so like a Dan Meyer style 3-act math task involving some videos, you know, delivering an intro to kind of, you know, draw people in. In Act 2, giving some information that students will need to solve the problem, and then that third act sort of the conclusion, the end of the movie, so to speak, to see what actually happens in the real world. So while we still strongly believe in 3-act math tasks and we use them quite often, we just want to let people know that that is not all there is to the math lesson. So that might help us with sparking that curiosity. But it's a means to getting us to fuel sense-making. And this is where we have to start making some sense of the mathematics. If we just get students interested and they solve a problem and then we move on or just go back to the old school way of teaching our math class, we really miss an opportunity for students to think and to build some conceptual understanding.
The third big thing is it's not in order of steps. It's not like we want to spark curiosity, then fuel sense making, and then igniting our next move. The igniting our next move, the third big idea, kind of encompasses everything that we're doing here. And this idea is all about feedback and assessment. What we wanted to talk about with igniting our next move is we're always assessing what's going on in those lessons and activities, and we want to take that information from our students and what we're seeing our students to do and what they're trying and what learning is happening, and we want to make that help us decide what's going to do next in that lesson or what's going to happen next tomorrow in the next day. So igniting our next move is kind of about gathering information of what's happening during the spark and the fuel parts, and then using that to guide us on our next part.
So now what we're going to do is take an opportunity to kind of dive into a problem, and we're going to start by trying to spark some curiosity out there. So what we're going to have you do on a piece of paper, or maybe it's on a digital tool you're using right now, we're going to have you thinking about what you notice and wonder. You might want to jot these down or maybe type them in if you're using some sort of note-taking tool. And what we'll be doing is also be sending down another question from Knowledge Hook. I know Michelle's also going to be posting a video for you in the chat. So if you're not in the Knowledge Hook game show, you're going to be able to access it from the chat in just a moment once that's posted. We'll get this slide up here as well. And basically what we're going to have you do is check this video out and think about what you notice and what you wonder. It should be coming down to your Knowledge Hook devices right now. If you don't see it, you might have to hit the refresh button. All right, I'm also going to repost the link to get you into the game show. You can join at any time, so if you're late, no worries. You can just head to khmath.com/play, and the game pin is Guru2447, and you're going to join as a guest. All right, we'll give you a little bit of time to watch that movie and think about what you notice and wonder. You can type those into the Knowledge Hook game show, or you can put them right into our chat if you aren't with us in the game show. So let's take some time to do that, and we'll be right back. All right, we've got some people in the Knowledge Hook game show typing in some noticings and wonderings. Feel free in the chat box inside of Blackboard to do the same thing if you're not in our game show. And we'll go through a few of those in just a moment. All right, we're going to give you about 20 more seconds in the game show, and then we're going to take a look at some of those noticings and wonderings. Again, if you're not in the game show, feel free to type them right into the chat box in the webinar, just so we can get some thinking out on the screen. All right, so in our Knowledge Hook game show window, we see that quite a few people have locked in, and we've got quite a few different noticings and wonderings. We've got lots of basketball nets, lots of shapes. I wonder why you're showing this to us. Yes, you will get a lot of students that will ask things like, what the heck are we doing here? Which is all right as well. You know, over time, as you use more of these types of tasks, students just they just buy into the culture. And it becomes a really fun thing to do to get them talking in their classroom. We've got people looking at basketballs with different heights. We've got partial windows. Recently, I did this at a workshop, and someone noticed that like the fire escape or the exit sign at the back of the gym is actually blocked, which is probably not allowed. So I will definitely let that individual school know. Total health and safety violation. So lots of really good things going on here and lots of noticings and wonderings. So I do appreciate that. what we're going to have you do is think about this for a second. You've done your notice and your wonder. I wonder if I was to give you something like this. If you were to make us a prediction about how many chairs you think or how many people could fit in this gym. All right, I'm going to give you a better look at it here. That's what you're up against. And I'm going to send this down to you in Game Show. We're hoping that you will show us some of your thinking. This is going to be an opportunity for us to utilize Game Show's ability to upload solutions. And on this next question, as it gets sent to you, you're going to be able to type in how many chairs you think will fit in the gym. But we also want you, after you submit, to hit the Upload Solution button and give us an idea as to what you're thinking. Like, what sort of math are you doing in order to come to that prediction?
And Kyle, that Upload Solution button, that will only show up if I click Submit, right?
Absolutely. Good call. Yes, you will not see that Upload Solution button until you submit. So the idea here is they want you to do the work in order to submit an answer and then upload your thinking.
Oh, and one more question. That 18 means you've already counted that to be 18 shares showing.
Absolutely. I did you a little favor there. I might not do that if we had a lot more time. Probably make you have to grow through it. But yes, 18 shares there, but the configuration is completely up to you. So what's this going to look like? I'd also like to, keep in mind that there are some digital tools like matthews.ca that can be helpful. We're going to have a direct link to that later that will be really helpful for you. And I'll post that into the chat right now if you're interested in using their Tile app, or you might consider using the Math Learning Center's Number Pieces app, which I'm going to post in the chat right now as well. So we'll give you a little bit of time to do some thinking. And then hopefully we'll see some upload solutions come in so we can paste them into the chat box for everybody to see.
Just as a reminder that when you click the Submit button in Knowledge Hook, one of the great features that we love is that kids can take a picture with their mobile device of the work they did on a piece of paper. And if you did that too, like to help with your estimate, you did some sort of thinking to take that 18 and say what happened to fill that gym up. We'd love to see some of that work here. Oh, we're seeing one come in right now, so that's awesome. The interesting thing is on our end, we get to see like a green little button shows up, and we get to see that somebody submitted a solution. So if you're thinking of using this in your classroom, like you can do that too. And kids, I make it mandatory for kids to take a picture of that work, and it's so great. And instead of just a multiple choice kind of question, we get to, on the big screen, we get to see each other's solutions and talk about the ability of them or how good they are. So we'll give you a few more seconds to put a couple more in, and then we will move on. Some of our solutions, or people are writing comments and saying, like, we put a number in Knowledge Hook is right now set up to put a number in as your answer, and that's where the explaining the solution part is the part that we were thinking that you would write on a piece of paper or draw on something, and then you could take a picture of that. So that's what I have my students do, is do it on their paper, and then they take a picture of it instead of typing it all into the computer. I find that speeds it up too. Kids are slow on typing. So we're gonna collaborate a couple of these solutions and throw them down. Oh, you're seeing one right now. Kyle's already thrown it up here. So we're seeing one solution that's 252 chairs, and it looks like they've said there's 14 or so chairs across. So 14 by 18, 14 groups of 18. They're saying about 252. So that's 14 across. Interesting. Okay, let's see. Oh, somebody's typing in the chat window here. We have 18 by 16, so it's 288. Plus open space makes a guesstimate of 300. I like how they threw in a little extra there. Some people are saying, oh, with 18 across, there's definitely some multiplying going on here, and we're looking at filling this space up with chairs. Somebody said 12 across. Kyle's throwing a picture in here with somebody showing their work here with a 24 by 12 grid, and showing that multiplying with looks like an area model going on there. So that's very nice to see. Do we have another solution there to show, Kyle, or
one more?
Here comes another one. It's going to show up any second here. A little bit of buffering going on in my screen. Oh, there it is on my screen. So we got 18 by 10, 180 chairs. Ah, interesting. And approximately 30 in each. Oh, 30 in chairs for teachers. Don't forget about those teachers. Interesting. Very nice. Great solutions coming in here, or great thinking for their predictions. These are just our predictions. I think we're going to get a little bit more technical here, Kyle.
Yeah, I think we're going to give you kind of an overhead here of this gym. This is actually John Campbell Public School in my district, Greater Essex County District School Board. Michael Huggard and the great team from John Campbell invited me in to do some learning with them, and what a great day. They were setting up the gym, and we came up with some ideas to have some fun mathematically. So this is sort of what you saw, except you didn't see the front stage that is going to be set up. You also didn't see the center aisle, so this might impact some of your thinking. And really what we're going to have you do is sort of improve your prediction a little bit. I'm going to reveal the following, and we're going to see if you can improve your prediction. I'm going to go ahead and send down our next question in our game show in just a moment, but I want you to think about how you can improve your prediction, and then we'll be coming back to sort of consolidate the sense making from this particular problem. So we'll give you a few moments to do that, and then we'll be back to work with you. Awesome. So we're seeing Eli, and we're seeing Jay, as well as we've got Kit sharing some updated answers as well. Awesome stuff. Now the intentionality here, and what we'd be hoping to do in our classroom, and it would really depend on what grade level we were at and where my students were in terms of their understanding. But really what we're going to end up with here is a lot of chairs. And I mean, students can one-to-one count this, or they could, obviously they could use a calculator, but really what we want them to see is that there's ways that we can decompose these numbers down. So for example, some students might actually look for 10 by 10. In this case, it should be a square, but because of the spacing between the chairs, it looks more like rectangles. But if I look at those 10 by 10 squares of chairs, we end up with two 100 chair groups. And that leaves us with another 10 by 8 and a second 10 by 8 group. So just by chunking these down, or using the distributive property to decompose our factors, this can really make the math a whole lot easier for us. So those of us who have used number talks before might be using similar strategies. Here what we're trying to do is really show this concretely. And I know obviously this isn't concrete when it's digital like this, but you can imagine in the classroom that what we could actually do is, instead of using individual seats or individual tiles for these 360 seats, we could actually be using base 10 blocks. So using a series of base 10 rods, you would see that you'd have 18 10 rods on one side of the gym and 18 10 rods on the other side of the gym. Students could then even swap them out, right? They might see that, wait a second, every 10 rods is going to give us 100 flat. So these base 10 blocks can be really helpful with trying to help students understand how multiplication works, as well as giving them strategies that won't require them to have to always go looking for the calculator.
Yeah, and I'm glad Kyle has shown this, especially the diagram that he's shown here as me being a high school math teacher. I love that this is happening in our elementary grades, because this diagram, if you're a high school math teacher and you use algebra tiles quite regularly, this looks very familiar. Because what we do is we translate, instead of a 10 by 10, we say it's an x by x square, and that's actually a square as shown. Or if it's a 1 by 10, we show that as a 1 by x rectangle, and we use tiles to represent algebraic expressions, and they look identical to this picture. So we're connecting ideas from elementary into high school, and that we want to fuel that sense making all the way up.
Awesome, awesome. And I don't know if you can hear, we actually are making math moments that matter. John's cat is actually giving us quite a few signals that he or she, I'm not sure which it is, but is really interested in what's going on here. So John's handling that, and I'll handle you folks here for a moment. You may also notice that we can actually transfer from this array using base 10 blocks right to an area model. So not only are we tackling number sense and numeration, but we could also be looking at measurement. And like John said, we could also be looking at algebra, patterning in algebra. We can easily take this problem and just take something out like instead of rows or groups of 10, we might be dealing with groups of X. We cover up how many chairs there are, and students can then start working towards their algebraic thinking. So here, as we simplify, we still see our 360 chairs. Now, we told you this one is a 3-act math task, and we wanted to spark that curiosity. Here, what we've tried to do is really outline some of this fueling sense making. It really depends on what grade level you're at. If I'm in a grade 5 classroom, my consolidation might look a whole lot like what we just shown. But if I'm in a grade 10 classroom like John might be, he might be looking at this from a quadratic standpoint, or he might be looking at this as with his algebra tiles and modeling with some unknowns. So really easy to sort of see how you can go from elementary all the way into secondary. But like every good 3-act math task, we want to show you what actually happened. So we're going to put that link up on the screen, or you will have access to it right from your window in Knowledge Hook. So that'll be coming down to you in just a moment. Now, what we want you to think about, though, is that there is an answer here of 286 seats. So if there's 286 seats, I want you to think about what actually happened when they went to set up this particular gym. All right, we might want to hold off on the video and think about what might that look like. So we'll give you a moment to think about that. And where would we get that number 286 seats? What might the setup look like in the gym when they set up for graduation? All right, so on your game show screen, you should see the same slide, 286 seats. And we're looking for a few brave souls to show us how might those seats have been configured. We all know in the real world we plan to do certain things. For me, hey, I try to fix my car sometimes. That never seems to work out. But in math class, the same is true. I might have a plan for how many seats I want to get into this gym. And on paper, it looked beautiful. It looked like everything was going to work out just fine. But we only managed to get 286 seats. I wonder what are some possible configurations. You might want to just chat it out in the chat box, but if we have some folks willing to model this for us in game show, that would be awesome too. Always love to be able to take your work and showcase that up on the screen, just like we would with our students. So take a moment, and we'll come back in about 30 seconds. All right, friends. So we're going to, in about 20 seconds, we're going to end the game show question. I hope that you're seeing that what we're trying to do here is kind of stretch out that fueling sense making. So we gave you an opportunity to make a prediction earlier. Now, it really depends on where you were at in your own mathematical thinking. Obviously, as teachers, most of us are probably going to be seeking an algorithm or using an algorithm to answer some of these problems. But for my students who may not be so dependent on an algorithm yet, they might be able to draw or use manipulatives to model some of their thinking. And I would really promote doing that early and often to ensure that students understand what multiplication really is and how they can get creative in breaking problems down. So then we actually decompose this problem using actual dimensions that we had given you, or at least hinted towards them when we gave you the overhead view of the gym. And then now finally we're giving you an answer and asking you to kind of work backwards a little bit here and think about what might that look like. And in my classroom, I'm probably going to ask my students to show as many different ways to configure those seats as possible, right? So I want to see different ways, seeing them chunking them or grouping them up into different chunks, which really promotes their understanding of the distributive property and multiplication. All right, so now we're going to give you a moment to actually see this gym set up nicely and with 286 chairs. So go ahead and have a look. Appreciate those who uploaded solutions with their thinking. And we'll give you a moment to do that before moving on. All right, so we ended up seeing a gym looking kind of like this. Plans changed a little bit based on what we originally planned for, and ironically, when we took the first shots for this problem, that was somewhere in the middle of the year when they started thinking about graduation, and I was lucky enough to make it by on graduation day to get some of these shots. So what they ended up doing, I believe, was 11 by 18 and another, no, what was it? 11 by, 11 by, was it 16? Yeah, by 13. So it was 13 deep instead of 18 deep. And I believe their logic was, and this was the grade 8s who came up with this, not only did they not require as many chairs as they initially thought when the parents had sent back their reservations or their RSVPs, what they had done is actually given them some more leg room to actually spread out the chairs a little bit. So, you know, they did some problem solving first and then came to the conclusion that they really didn't need so many chairs. So what we want to do is take a moment to kind of explicitly take you through this problem. So John's going to help us out with understanding some of the elements that can be good for sparking curiosity, not limited just to a 3-act math task like we saw.
And also not limited to just this task. So we want to think about there's lots of different tasks out there that can spark curiosity, and so I'm going to relate to this one, but also think in general. So if you think back to how we try to spark your curiosity, one thing we're always trying to do is to get our students to notice and wonder. And a lot of times we skip over this, especially in high school. We just jump right into the math right away. And if you follow Dan Meyer, he's famous for his math dial, where he would say that, you know, with us math teachers in high school, we will crank the dial up to like think of volume, like we crank it up super loud. We're going right to the super math right away, like all big math ideas right away. Whereas if you slowly bring the volume up, which means slowly introduce more mathy type things, kids will ease into that, and by the time that the volume is loud, it's not such a shock. that they're into with this math problem. So we want to ease into that with sparking curiosity, and one way we always do that is with noticing and wondering. And kids can bring out ideas of things that they're noticing and wondering. You get to have a conversation about them, which brings those students into it, and a lot of times that they'll be free to give those ideas out that can spark where you're going to go. And also the noticing and wondering can help decide where the lesson is going to go. We were always going to go with how many chairs were in that gym, but a student may have also, or one of you may have also asked how many chairs are in that gym, and if we picked that to do as a group, that student or you may have been like, oh, that's the question that I wanted to know about. That's the one that I put forward, and that kid feels great that day because of that. Other things that we do is we always try to incorporate estimating and predicting. Actually, if you look through the K-8 math curriculum in our curriculum documents, estimating shows up way more than calculating, like way more. And so we want estimating, predicting to always happen, and kids are easily can estimate, and it's harder to calculate. So we want to slowly crank that dial up by having them estimate and predicting, and that will also get them buy-in into the problem. We're slowly easing them into doing some math. It's a great buy-in for them. We always try to incorporate storytelling in what we're doing, and as you know, as teachers, that when you tell a story, kids are eager to pay attention, and we try to incorporate that into the math lessons that we do. You'll notice that a lot of storytelling can happen around real-world problems, kind of like this. Kyle did not leave any details out about where this gym came from or what was going on in the gym. That kind of tells a story about what we're doing and where we're going. Another thing that we try to incorporate is that trying to bring out any of that curiosity that can get that kids to wonder about that math. So those are the things that we always try to do in sparking curiosity, and we find there's an overlap with what's going on in sparking curiosity, because a lot of those, especially estimating and predicting, can fuel kids' sense making. And Cal's going to jump in and talk about that second piece on fueling sense making in this problem.
Absolutely. So as John mentioned, you know, we really try to do a good job at getting students in and wanting to really find out what the answer is. You'll find sometimes, I mean, for example, people often think that math has to be relevant to students. And I don't know about you, but I personally don't really care about how many chairs can fit in the gym, but the way you present the task and the way you present the idea is what will sort of draw a student in. So giving them an opportunity to predict and sort of argue at an answer with a neighbor is really important. So we really focus on that, but it's all in order to get us to this place where we can fuel sense making. And we can't really ensure that students understand the math they're doing when we rush to the algorithm. So we really want to start with concrete manipulatives and visuals where necessary. Depending on your grade level, it might seem more reasonable to begin with visuals versus concrete. But I would argue that from K to 10, there's a lot of opportunity for us to be using concrete manipulatives for students to actually physically use and manipulate in their hands before we move to the visuals. If we're jumping straight to the algebra, we're going to lose a lot of students along the way, right? Either from disinterest or simply just not understanding where the algebra is coming from. So we really want to make it nice and connected from the concrete and visual to the symbolic stage. We want to promote tools and representation. So those concrete manipulatives could be considered a tool, but there's all kinds of other tools that we could be utilizing as well. A calculator is even a tool. So really just making sure that students have access to different tools to help them find solutions, but then to also help represent their thinking. All right, so whether they're using the tool to actually do the math or using the tool to help explain the math, both of those things are really important for students to begin fueling that sense making. And one of these pieces which will connect in the next piece and igniting your next move is this idea of selecting and sequencing student work. We're going to be doing a lot of anticipating when we plan a task and before we deliver a task, but during the actual class, we have to spend a lot of time really thinking hard about which tasks, which student tasks do we want to select and which ones in which order do we want to present them in to share them up, and then help with the consolidation. So after we're sharing what the students have done, we then have to determine where do I need to go, what other pieces of information, what other information hasn't come out of the student work in order for us to handle. And that might include us using direct instruction to actually get at those missing pieces. So that takes us through that fueling sense making. And as John mentioned, igniting our next move is really done throughout the entire process. So John will take us through that.
Yeah, so as I said before, that igniting our next move is all about assessment. And this is not assessment like a quiz or a test. And sometimes people say, well, is that formative assessment? Like a quiz is formative assessment, and summative assessment is a test. This is not what I'm talking about. I'm always saying formative assessment is everything I do to gain knowledge of what a kid is learning and how they're learning, and anything that fuels what I can gauge from a kid. That's formative assessment. As soon as I slap a mark down on something, I guess you can say that that's summative assessment like a test. But what I'm talking about for igniting our next move is all about assessing where to go next for you as a teacher and what the kids are doing. So that's that formative assessment. That's hard to do because that means, like when Kyle was talking about selecting and sequencing work, sometimes that means we have to plan and anticipate what the kids are going to do before that directs where we're going to go. And that assessment piece is, where is the kid, how am I going to help the kid or the class get to this point I want to go. And there's a quote by Tom Schimmer that I always found super fascinating. He said, you have to plan with precision so that you can proceed with great flexibility. And that always stuck with me because, you know, it takes a lot of, sometimes we fly into lessons and we think, oh, it didn't go that great. And it's because probably we didn't spend enough time thinking about what the kids were going to do so that you were ready to jump and give them a hint, or jump and push them to the next level. So planning, it is hard work, I understand, but planning is something that we should underestimate. And that involves any kind of feedback that we're going to give kids, and we're planning to support the students everywhere we go. So it's mostly all about that and what we're going to say to the kids to push them forward. So that's what I mean by igniting our next move. We gather the information on the fly so that we can decide where we're going to go next that lesson, but also the next day. As me as a high school teacher, I used to always plan, like my whole unit was planned out for like 2 weeks, regardless of how the kids were going to behave or react to my lessons. And it's hard to think that I used to do that because I wasn't allowing to change my lessons based on what the kids were showing me or what they were learning or how they were learning it. So I always want to plan with precision so I can go ahead and proceed with great flexibility. So those are our three big things that we think have to go into all of our lessons to make them memorable for our students and make them matter. So again, that's sparking curiosity to start, get them hooked in. Fueling your sense making is so important, and probably the biggest thing that we're all doing anyway. We just want to make sure that we're accounting for it here, and then definitely talking about assessment as we go through. I think what we want to do next, right, Kyle, is we want to showcase another lesson that shows these three, that they're not just like a one-off for each time. It was like, no, they're not just also for 3X math problems or problems that involve real life or video problems. We're gonna show you a problem that's probably definitely the least amount of real life, but also the most common curriculum expectation from kindergarten through to grade 12. So let's see if we can catch on to which expectation we're thinking about here. We don't want to let the cat out of the bag too much. So what you're going to need, though, is you're going to need a piece of paper for sure. So grab a piece of paper. You got to do a little bit of drawing here with us. So a piece of paper, or wherever you're going to write down, any blank piece of paper or a napkin if you're sitting there, or grab a paper towel if you're in the kitchen like we are. Can you draw me on that piece of paper these two lines like Kyle and I have that separates your paper into these 4 areas? That's important. So we'll give you a sec here. I'll just keep rambling on while you do that. But we need those 4 areas because we're going to draw some stuff. Kyle, you want to join in here? You have a recommendation here?
Yeah, I've got a recommendation as well. If you want to explore a interactive tool, you might consider using the Matthews Tiles tool. I've got the link coming in right now to the chat box. So if you click on that, it's a beautiful looking link, I know. Nice and short and easy to remember. Definitely want to bookmark that. I didn't do a short link for it. But you might want to click with that if you want to actually draw what we're going to do on paper, it's fine. But what I'm going to find later is what we're going to challenge you to do. It's really helpful if you either have the manipulatives in the physical form or in the digital form so you can actually move them around in order to help make some sense. All right?
All right. So here's what we want you to do. So you've got your paper or you got the digital version. We want you to look at the top left corner. So we're going to get you to draw something in the top left corner of this page. And this is the shape we want you to draw there. This shape right here. Can you draw this collection of shapes in that fashion in the top left corner of your page, please? Go ahead and do that on your digital device. Or, as I said, if it was me, I was just doing this on a piece of paper. That's going to be great. With my students, I have them draw it on a whiteboard in my classroom, separated into 4 areas. On the top, they just draw those squares pretty quickly. It's not major that you're drawing a perfect square here. Just that collection of 4 squares. Kyle, I think, he's whipped something up here digitally already. I think he's going to capture that screen and he's going to throw it in here because we're going to draw 2 shapes to start. So he's showing you one that he just drew on this Matthews Tiles app. Here it comes. There he is. Just drew that up. So that one's done. So we're going to zoom back out to our page here. We've got that shape now in the top left corner of the page. Can you now kind of zoom in into your top right corner of your page? So also, I'm going to let a little bit of the cat out of the bag here. I'm going to call the shape we just drew, I'm going to call that figure 1. Some of you are like, oh, I know exactly where we're going now. That's figure 1. So we're going to draw figure 2, which is in the top right corner of the page. And can you draw me this shape, please, in figure 2, which is top right corner of the page, that one right there. Please draw me that shape in the top right corner of your page, and label it figure 2. If you label them, it'll be great for when you show off the next couple parts. That might take a little bit longer to draw. Figure 2. I think Kyle's got a digital whipped up here. It's coming through Matthew's app. Boom. There it is, figure 1 and figure 2. Okay, so we're going to give you some time here because we're going to do something different. Normally we just give you figure 3, but we're going to try to spark a little bit of curiosity here. So in the bottom left corner, you're going to draw figure 3, but we're not going to show you what figure 3 looks like. We want you to anticipate here what you think figure 3 looks like. Also, Kyle if you're running your game show or your iPad or your device has gone to sleep, you might want to wake it up. Kyle is going to send you a new question through the game show, which is this question, like what does figure 3 look like? Feel free to sketch it on your page and then take a snapshot of it with your mobile device and put that after you've clicked the I'm ready to share button, throw that into the Knowledge of Game Show and we'll see what some people's figure 3s look like. Kyle and I are very interested to see what you think figure 3 looks like. And then what we'll do is we'll show you what we think figure 3 is going to look like. But we'll give you a minute or two to draw and then put that into the Knowledge Hook. If you don't have access to Knowledge Hook or you haven't got it to work or you're sitting on a laptop and you find it pretty hard to take a picture with the camera and upload it, I understand you might just want to seem to wait, and we'll see what everyone else has uploaded.
And Deanna, I see it looks like you have a low, your connection looks like it's low, so that might be your issue there. And from Melissa, welcome Melissa, Guru2447 is your PIN. And I think Deanna is having a slow connection issue there, so. All right, waiting for a couple more solutions to come in through the game show there. Again, if you haven't tried the Matthews Tiles app, the links are in the game show window. So you can click them right from game show. That'll bring you there. Also keep in mind the Math Learning Center in the US actually has a bunch of apps as well, both on the iPad, on the Android device, as well as on the web. So really, suit yourself to which you prefer. They're all very useful tools.
Right. So what we've got, here's one that came in through our game show that Kyle did a screenshot so we could drag it over to the Blackboard app that we're using here to show you everything. We've got one of those. I wonder if you guys, so somebody drew this. Can you guys do me a favor in the chat window? Can you just say, yeah, if that's the same, and no, if that's different? I'll give you a sec here. Like, yeah, is that the same one you drew? Or no, that's not what I drew. Give it a shot there. Here's a couple of yeses coming in. We got must have meant that a few of you looked at it. Maybe oh yeah, do me a favor and just describe what you think it looks like. Joe's saying the figure's growing by 1 block vertically and 1 full row horizontally. I like that she's described that thing. I would have my students do the same thing. They draw it and then have them describe in words what's going on here.
And something interesting as well, I just saw another one come in through KnowledgeHook. At no point have we specified as to what this pattern, if this is even a pattern, we just asked you to predict. So really we're doing that intentionally so that every student in the classroom feels like they can draw what they feel. A lot of students are probably going to make assumptions, but even a student who may not necessarily feel super confident is going to make their version of figure 3, and they'll be able to justify it in their own words.
And another thing to add to that is the purposeful of the anticipation here is that Kyle and I strongly believe that anticipation also helps do feel the understanding. If kids, a lot of times in math problems, we give them everything up front. It's like we preload a math problem and it'll be like, here's this scenario, here's a whole bunch of numbers. Kids know and figure out, and I'm sure you did this when you were in school too, that these numbers have to fit into this somewhere. With holding information back like we've done here, we're trying to see, like, can you see what's needed? Can you see how things are changing? And that's so important to help with their feeling and their understanding. So we've got that one. Let's, you know what, let's jump over and Kyle to show what we thought it looked like. Let's see. So a lot of you said it was the same. Boom, that's the one that we thought it looked like. So if we say there's figure 1, figure 2, figure 3, I think now, if you see that, we thought the same as the one that was shown. Can you, we'll give you another 30 seconds here. Draw on your page what figure 4 looks like. Now, 1, 2, 3, draw figure 4, or describe it in the chat window. Some of you have taken to that, which is great. Go ahead and do that, please, figure 4. Okay, so we're going to speed things up just a little bit. So we're looking at figure 4. Let's see if this is what figure 4 looked like for you guys. So just boom, that's figure 4. That's what we were thinking. Anybody think that was figure 4 for them? Yes, no, maybe. I think so. So we got a couple of yeses coming in here. Here's that. So we did, that was the easy stuff. We had you predict. We wrapped our head around this pattern. Normal class, we just give them those 4 figures, and then we ask them something different. So I think you know what's coming. So what we're going to do is, there's the first 4 figures, but we're going to kind of tilt it up like this. We got figure 1, 2, 3. We know what 4 looks like, but we don't want 5. We don't want 6. We don't want 7. What we want you to find is and describe. Okay, so you can just describe this in the text or draw it on your KnowledgeHook game show. But we got about 2 minutes for this, just so we want to speed up and get to the next part. But what does figure 27 look like? So describe figure 27 looks like, and then we will show you a couple answers. Okay, so we've got a couple of answers coming in here, and a lot of you kind of caught on that. So somebody said, you know, it's a 27 by 29 plus the top and the bottom. People are catching on. I think they see it a certain way. I think most people see it this way, that you've got so many going across and so many going down. But so 27 by 29, 27 by 20 is always that plus 2. Now, a student of mine saw it this way. I want to show you what that looks like. So they said, you know, let's look at 1, 2, and 3. And they said, we all saw this, that there's the 2 kind of kicking around, and we can start to build our equation from that. But here's where I'm not sure. Maybe somebody saw it this way, but one of my students did. They said, you know what, on figure 1, there's 1 square there. But on figure 2, there's another square. There's like a 2 by 2 square there. And on figure 3, there's a 3 by 3 square there. So that's consistent. Like on a figure 4, it would be a 4 by 4 square sitting there, and so on. And then we can start to build our equation like that. And then they said, you know what? There's these extra rows here. So there's the square, the 1 by 1, the 2 by 2, and the 3 by 3. And then there's the blue squares are rows of 2. There's 2, like on figure 1, there's 2 rows of 1. And 2 columns of 1, and then there's 2 of 2, and then there's 3 of 2, and then on figure 4 would be 4 of 2. We start to build it this way. So we might not have seen exactly that, and we piece together how those numbers relate to the shape, and we start to incorporate how we represent 3 squared and how we can represent 6, and we end up with a nice expression where if we look at the term number compared to where these numbers start changing, we can be general and we can put an n in there instead of, say, 3 and 2 and 1. And we've got this nice expression that represents all shapes, and we can easily say that is the general shape, and we can use that to help determine 27, put 27 in there. And this is what we would do in high school. To start to build that. Kyle, do you want to show how they saw it and say some of your students saw it?
Yeah, based on, and I love something I do want to note here is that John actually presented this slightly out of order because he noticed that most of you saw it in a similar way, or at least the people who had shared through Knowledge Hook and through the chat window. So he wanted to share a different way of looking at it. So it sort of leaves you in a bit of suspense, having to sit there and wonder, oh, wait a second, is mine actually going to work out in the way that this other student's thinking had worked out? So we have a general equation here, or a general expression that works for this particular pattern, and clearly articulating here where our general term, this n, this figure number n, appears in this expression. Well, we can go back and think about, for a second, this slightly differently and look at this as just big rectangles wrapped in these 2 green blocks. So we can actually break this down a little bit and note that, wait a second, we actually have a 1 by 3 rectangle in the middle, and then a 2 by 4, and then a 3 by 5, and then eventually we're going to have a 27 by 29, as some people like Christine and Mandy had articulated. But what we're really trying to show here and trying to fuel this sense making is that by visualizing it, this can really help some other students see things a little bit differently. You'll notice that our work with arrays from grade 3 is really important here, because if I don't understand how to build an array, I'm not going to be able to take a pretty difficult pattern like we see here and actually create a general expression for it. So as we slowly decompose the numbers, or the number of squares we have, what we're going to see here is that relationship between n and the extra 2 in each case. So if we break this down, in our first term, we have a 1 by 3, or a 1 by 1 plus 2, and then a 2 by 2 plus 2, and then a 3 by 3 plus 2. Well, guess what? We can actually write that a little bit differently, and we can actually put in our n value here. So what we end up with is another way, another expression that's actually equivalent to the first. And we can then give students the task of figuring out, wait a second, how could both of these actually work, have them test this theory, have them try to wrestle out these ideas together, and then really look at if there's other ways that we might be able to visualize this particular problem. So while we're coming to a close here with just a few minutes left, what we did want to do here, not only by explicitly explaining our 3 elements that we feel make math moments that matter, we also wanted to give you 2 different examples. One that was focused on a real-world 3-act math task to spark curiosity and fuel that sense-making, and then another that really isn't relevant whatsoever to the real world. However, there's something that was curious about that delivery. So we want you to sort of think about that as some takeaways. And we'll have John sort of quickly summarize our 3 main elements, and then we'll be giving you guys access to a few resources that we didn't get to discuss here today, but will help you with trying to hit by sparking that curiosity, fueling sense-making, and igniting your next move.
So just a quick recap of what we did on that particular patterning task is we did use noticing and wondering in the form of anticipation. So we didn't say notice and wonder, but we wanted students to wonder what was going on in the pattern. We noticed those things. We made some anticipation and predicting. We did I guess with that predicting, there was not much storytelling here, but you noticed that the math file started low and we turned it up slowly. We didn't jump in to say, hey, just calculate what figure 27 looks, how many squares in figure 27. We slowly cranked that up. And also we didn't say how many squares. We said, it's a slight differential in what we said, but huge in what came out of what you guys did. And I didn't say how many squares. I said, what does the 27 figure look like? So we had to describe it, and that helped you decide on how it should look, and that helped you figure out how many squares would be there. If I had said how many squares, a lot of you might have made a table of values and then been stuck wondering how to go next, since it wasn't a linear fashion. So jumping over to our fueling sense-making, we did try to make things visual. We connected ideas together, and we'd normally selected and sequenced work based on what people drew. We saw some of those. We highlighted those in a particular order. Normally we would have seen different solutions on how to figure out how many squares are in those, and highlighted that work with our students. Last, we're always, again, still doing the formative assessment because it allows us to stay on the fly and adjust where we're going and what's needed to do. But we were always trying to get to this place where we could show these 2 expressions and how they're equivalent, and that's exactly where we're going to go next with our students. So that's our 3 big ideas that we think fit so many different lessons that you can try in your class. And as Kyle said, it doesn't have to be about a real-world problem. It can be non-real world. You could try to fit these 3 things in all of your lessons going forward. Last, we're going to show you this slide right here, which Kyle's got a link here, and if you type that link into your web browser, it'll bring you to this Google Doc. And this is where we go to grab resources to help spark curiosity. A lot of those things we did not create. Most of them we did not create. We used them to help spark that curiosity. These are the fuel sense-making resources are some learning that we've done along the way. Kyle's made a number of videos to help people show how so many ideas connect together from elementary into high school. Recommend you checking Graham Fletcher's videos out about how multiplication connects through the primary grades into the elementary grades, and he has a number of different on multiplication and division and subtraction and addition. Very nice there. So I think there's an extra part here, and there's also in that Google Doc some things to read further about how to ignite your next move and how we think that fits together. So those are the 3 big ideas. I'll put that link. We will put that link, I think, into the. You did? You just put it in already. What a guy. So we'll leave this slide up because these are the 3 big ideas. Kyle, you want to add anything before we sign off?
No, I think we just want to thank you all for joining us. We know it's busy time of the year. The school year's just underway, and you chose to hang out with us and do some professional learning on a Monday night. So we do want to thank you for that. Feel free to contact us at any point. Our sites and our Twitter handle are up on the screen, so we're really looking forward to continue learning with you all, and we hope that you found some value in this session, and we will see you again sometime soon for another Adobe Connect.
All right. Thanks very much.
Thank you, Cal and John. So right on time, so that's perfect. It's almost to the second. It was really a fantastic session, and thank you so much for being so creative and so enthusiastic. These are by far the most interactive sessions I have the privilege of moderating, and I really love them. It was really a session of very high level of skill and creativity, and I particularly love it when you guys invite participants to play math game on the Knowledge Hook and post the results on the fly, including drawings. That's really fantastic use of technology. It's really great. I also want to thank all of you for being such incredibly motivated participants and for taking time away from your family to join us over OTF Connects. We have a few more slides that I just want to share with you very quickly. We have a particularly rich program this season. As you can see, we have a number of math-related sessions in the coming days. We have 2 this week and another 2 next week. I am moderating for Vicky Morgado next Monday on October 30th. It's a session titled Bring Your Own Device to Class. Yes, you can. I think it will be extremely interesting. Vicky is a new facilitator. It will be her first session, and we still have lots of places available for that session. So if you know anyone interested, please pass the invitation along for next Monday. And I'm also moderating for Matt Aldrich on November the 2nd. The title of his presentation is Mathematize This, and he's a really fun guy to listen to as well. Really, I enjoy him as well. So again, please pass the invitation to your colleagues for November the 2nd. Before I talk about this slide, let me just paste the resources for our calendar into the chat box, as well as for past webinars, in case you need to access them. I just want to let you know of another opportunity provided by OTF and the Ministry of Education. If you're a qualified teacher and you have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy, and I'm going to paste that link as well. So if you guys want to apply for it, you just go to that location. We really value your feedback. It's very important to us. When quitting Blackboard, you will be presented with the opportunity to give us your feedback on tonight's session and fill a short online questionnaire. I'm sure it will all be very positive, but we really love to get your feedback. It helps us improve our program. The survey only takes a few minutes, so if you could do it right away tonight, that would be great. And if you can't, we will send you an email tomorrow with an opportunity to fill up that survey again. As a new feature of our webinar, you will also receive a certificate of participation that you can add to your resume, and that certificate is available for 48 hours. So we warmly encourage you to do that either tonight or tomorrow. And I will post the links in the chat box as well for the feedback survey and for the certificate of participation. I'm also going to post in the chat box the resource page for tonight's session. It's not live yet. It will be live tomorrow morning if you want to access the recording and the links that we have shared tonight. So finally, I also would like to invite all of you to a conference on financial literacy next week, Friday and Saturday actually, at the Holiday Inn near the airport. There are still a few places available, but registration is ending on Wednesday. So if you're interested, there's still time to register, but you have to do it before Wednesday. I'm going to post the link if you are interested, and just follow that link if you wish to register. So that's it. I'm now going to end the recording of the session. Please feel free to remain online if you wish to ask Kyle and John additional questions once the recording is ended. Otherwise, I wish you all a very good evening. Thank you once again for your participation in tonight's session. We certainly hope to see you soon on OTF Connects. Bonne fin de soirée à tous et à toutes et encore merci.